Darkness. Real darkness. The kind that exists far beyond Earth, beyond sunlight softened by atmosphere, beyond anything human beings were ever meant to stand inside. And hanging in that endless black is Jupiter, a planet so enormous that more than 1,300 Earths could fit inside it. A storm-covered giant with gravity powerful enough to control an entire miniature solar system of moons orbiting around it like prisoners. Most of those moons are frozen, ancient, and dead. But one of them is different. One of them looks less like a world and more like an open wound. Its surface explodes constantly with volcanic eruptions so violent they launch molten rock hundreds of miles into space. Rivers of lava cut across plains of sulfur. Entire mountains rise taller than Everest before eventually collapsing back into the chaos below. This moon should have died billions of years ago. Every rule of planetary science says a world this small should have cooled, hardened, and become just another silent rock drifting through space. But Io never cooled down. Io never stopped burning. And the reason is terrifying. Jupiter itself is slowly tearing the moon apart. For most of human history, nobody understood what Io really was. When Galileo first pointed his telescope toward Jupiter in 1610, he saw 4 tiny lights orbiting the giant planet. Those lights became known as the Galilean moons, Io, Europa, Ganymede, and Callisto. At the time, the discovery shattered humanity's understanding of the universe because it proved not everything revolved around Earth. But Io itself remained a mystery for centuries. Even with more advanced telescopes, astronomers could only see strange colors on its surface: yellows, oranges, reds. Nobody knew why. Some scientists guessed minerals. Others thought frost or strange chemistry might explain it. Nobody imagined the truth because the truth sounded impossible. Io was alive. To understand why Io is so horrifyingly active, you first have to understand how planets and moons normally die. Every rocky world begins hot. During planetary formation, massive collisions release enormous energy. Radioactive materials buried inside planets generate heat. Gravity compresses matter until entire worlds become oceans of molten rock. But over time, that heat escapes into space. Big planets cool slowly because they contain huge amounts of internal energy. Smaller worlds cool much faster. Their cores freeze. Their geology shuts down. Volcanoes stop erupting. Tectonic activity ends. The surface becomes ancient and motionless. That happened to Earth's moon billions of years ago. Mars is slowly dying the same way right now. This is the natural fate of small rocky worlds. Io refused to follow that fate. Io is only slightly larger than Earth's moon, roughly 3,640 kilometers across. By all normal expectations, it should be geologically dead. Instead, it is the most volcanically active object ever discovered in the solar system. More than 400 active volcanoes cover its surface. Lava erupts continuously. Entire regions reshape themselves in real time. Scientists estimate Io resurfaces itself so rapidly that most features on the moon are younger than 1 million years old. In geological terms, that is almost unbelievably young. On Earth, some rocks are billions of years old. On Io, the ground beneath your feet might be younger than human civilization itself. The reason for this endless violence is gravity. Io orbits incredibly close to Jupiter, only about 422,000 kilometers away. That might sound distant, but Jupiter is so massive that its gravitational pull at that range is overwhelming. Io races around the giant planet once every 42.5 hours. But Jupiter alone is not the full story. Io shares its orbital neighborhood with Europa and Ganymede, 2 enormous moons whose gravity constantly tugs on Io in a precise rhythmic pattern known as orbital resonance. Every time the moons align, they pull on each other slightly. Those repeated gravitational tugs prevent Io's orbit from becoming perfectly circular. Instead, its orbit stays stretched into a slight ellipse. That tiny distortion changes everything. As Io moves through its elliptical orbit, its distance from Jupiter changes constantly. When the Moon swings closer, Jupiter's gravity squeezes it harder. When it drifts farther away, the pressure relaxes slightly. Then the cycle repeats. Over and over. Forever. The entire Moon physically flexes as it travels around Jupiter. Imagine squeezing a rubber ball repeatedly in your hands. The material inside heats up from friction. Now imagine that rubber ball is a moon made of solid rock and the hands squeezing it belong to the largest planet in the solar system. That process is called tidal heating, and on Io it generates staggering amounts of energy, more than all human civilization uses combined. The rock deep inside the moon melts under the pressure. Magma rises toward the surface. The crust cracks apart. Volcanoes erupt continuously because the squeezing never stops. If you could somehow stand safely on Io's surface, the experience would feel unreal. The first thing you would notice is silence. Absolute silence. Io has almost no atmosphere, which means sound cannot travel. Volcanoes erupt in total quiet. Lava fountains explode upward without a roar. Massive plumes launch into the sky without thunder. You would only see the violence happening around you in complete silence against the blackness of space. Above your head, Jupiter would dominate the sky like a giant wall of swirling clouds and storms. It would appear many times larger than Earth's moon looks from our planet. The great red spot would stare down like an enormous eye hanging in darkness. The surface itself would look alien beyond imagination. Plains of yellow sulfur stretch toward the horizon. Red and orange volcanic deposits stain the ground like burns. Black lava fields cut across frozen sulfur dioxide frost. Towering mountains rise sharply from the landscape, some reaching over 17 kilometers high, nearly twice the height of Mount Everest. Strangely, these mountains are not volcanic. They are giant blocks of crust forced upward by the unimaginable stresses constantly deforming Io's surface. Nothing about the landscape feels stable. Nothing feels permanent. Among Io's most terrifying features are its enormous volcanic depressions known as paterae. Some stretch hundreds of kilometers across and contain active lava lakes glowing beneath thin crusts. The most famous is Loki Patera, the single most powerful volcanic system in the solar system. Its lava lake spans roughly 200 kilometers. Periodically, the cooled crust floating on top becomes unstable and sinks, exposing fresh magma beneath. When that happens, the entire region brightens so dramatically that telescopes on Earth can detect the change from hundreds of millions of kilometers away. Human beings can literally watch a volcano erupt on a moon orbiting another planet. Io's eruptions are unlike anything on Earth because there is almost no atmosphere to contain them. On our planet, air slows volcanic explosions and traps ash clouds. On Io, eruptions blast directly into vacuum. Plumes can rise more than 500 kilometers above the surface before gravity pulls the material back down. Some eruptions spread giant rings of sulfur deposits over areas wider than entire countries. And the lava itself is unbelievably hot. Some flows exceed 1,600 degrees Celsius, hotter than nearly any lava seen on modern Earth. Scientists believe Io may still erupt the same kind of ultra-hot magma that existed on the early Earth billions of years ago when our own planet was young and violent. But Io's destruction does not stop at its surface. Every eruption blasts sulfur, oxygen, sodium, and dust into space. Jupiter's magnetic field captures much of this material and drags it into a giant ring of charged particles surrounding the planet called the Io plasma torus. About a ton of material escapes from Io every second. The Moon is literally bleeding into space while Jupiter collects the debris around itself. This interaction also creates one of the most dangerous radiation environments in the solar system. Charged particles trapped by Jupiter's magnetic field accelerate to lethal energies near Io's orbit. An unprotected human there would absorb a deadly radiation dose incredibly fast. Even spacecraft struggle to survive. NASA's Galileo probe suffered severe damage after years inside Jupiter's radiation belts despite heavy shielding. The discovery of Io's volcanic activity completely changed planetary science. Before Voyager 1 reached Jupiter in 1979, scientists believed small worlds became geologically dead relatively quickly. Then Voyager captured an image of a giant volcanic plume erupting from Io's surface in real time. At first, researchers thought the plume was an imaging error because nobody expected active volcanoes beyond Earth. But it was real. Io instantly rewrote everything scientists thought they understood about geological activity in the solar system. It proved tidal heating could keep worlds alive long after they should have frozen. That discovery eventually helped scientists understand Europa's hidden ocean, Enceladus water plumes, and the possibility of habitable environments far from the warmth of the sun. And yet, despite everything Io has taught us, it remains strangely ignored. Europa receives attention because it might support life beneath its icy shell. Enceladus fascinates scientists because of its underground ocean. Io has no oceans. No life. No hope for biology. It is simply a world being tortured to death by gravity. So mission after mission passes it over in favor of moons with greater astrobiological appeal. Meanwhile, Io continues erupting in darkness, reshaping itself endlessly while humanity watches from far away. And eventually, even Io's suffering will end. Over enormous stretches of time, tidal interactions slowly alter the moon's orbit. Scientists believe Io may gradually spiral closer toward Jupiter. As it moves inward, tidal forces will become even stronger. More heating. More eruptions. More destruction. Eventually, far in the future, Io could cross Jupiter's Roche limit, the distance where tidal forces become so strong they overcome the moon's own gravity. If that happens, Io will not crash into Jupiter. It will be torn apart. Slowly shredded into streams of rock, sulfur, and molten debris that spread into rings around the giant planet. Jupiter will wear the remains of its tortured moon like jewelry. Until then, Io will continue burning. It will continue bleeding sulfur into space. Volcanoes will continue erupting silently beneath Jupiter's shadow. The moon will keep fighting to remain geologically alive even while the very force keeping it alive slowly destroys it. No other world in the solar system works this hard to survive. And no other world pays such a brutal price for the orbit it keeps. If you watched a sunrise on Io, it would not feel anything like morning on Earth. There would be no birds, no wind, no clouds glowing orange above an atmosphere filled with life. The horizon would remain sharp and black because there is almost no air to scatter sunlight. As the sun climbed above the volcanic plains, frozen sulfur dioxide covering parts of the surface would begin turning directly from solid frost into gas. Io's atmosphere is so thin and unstable that it literally freezes onto the ground during the long night and then reappears when sunlight returns. Entire sections of the moon breathe in and out every single day. The atmosphere is temporary, fragile, barely real. And while the sun rises, the surface never rests. Somewhere beyond the horizon, a volcano erupts. Another lava lake overturns itself. Another crack splits open under the stress of Jupiter's gravity. Io is not a world with occasional geological activity. It is geological activity. Every landscape on the moon exists because of constant destruction. There are no ancient impact craters preserved for billions of years like the ones covering our moon. Io gets hit by asteroids and comets all the time, but the evidence disappears quickly because fresh volcanic material buries everything. The surface renews itself so aggressively that scars cannot survive. Imagine Earth replacing its entire outer skin over and over again until history itself vanished beneath lava. The strangest thing is how organized the chaos actually is. Scientists studying Io noticed that its volcanoes are not randomly distributed across the Moon. Many eruptions cluster in regions where tidal stresses from Jupiter should be strongest. In other words, if you map the volcanoes carefully enough, you can literally trace the invisible grip of Jupiter's gravity across Io's crust. The Moon's geology is a physical record of being squeezed by another planet. Every eruption is part of a larger gravitational machine that has been running non-stop for billions of years. Deep beneath the surface, many researchers believe Io may contain a global magma ocean, not scattered pockets of molten rock, but an enormous interconnected sea of magma extending beneath much of the crust. Imagine standing on what looks like solid ground while knowing that only a few dozen kilometers below your feet lies an ocean of liquid fire hundreds of kilometers deep. The crust of Io may essentially float on molten rock the same way ice floats on water. That means the surface is less like stable ground and more like the fragile lid of a boiling pressure cooker. Cracks open constantly because the pressure underneath never truly relaxes. One of the most terrifying places on Io would be Pele, a giant volcanic region named after the Hawaiian goddess of fire. Pele produces enormous plumes rich in sulfur compounds that spread outward across the surface in massive red and black rings visible even from orbit. The eruption columns can rise higher than the distance between New York City and Washington, D.C. before collapsing back toward the Moon. Imagine standing nearby and watching a mountain-sized cloud of volcanic material rise silently into space while Jupiter fills half the sky behind it. It would not feel natural. It would feel apocalyptic. The temperatures near some of these eruptions are so extreme that scientists initially struggled to explain them. Many lava flows on Earth erupt between 700 and 1,200 degrees Celsius, but some hotspots on Io exceed 1,600 degrees Celsius. That is hot enough to melt rocks that almost never melt on modern Earth. Researchers believe these eruptions may resemble the ancient ultramafic lavas that flowed across Earth more than 3 billion years ago during the Archean Eon, when our own world was still forming its continents and oceans. In a strange way, Io may be preserving a version of Earth's ancient past that disappeared from our planet long ago. But the violence of Io does not end with lava. Jupiter's radiation environment transforms the space around the Moon into something deadly beyond human imagination. The gas giant possesses the largest planetary magnetosphere in the solar system, a gigantic magnetic bubble stretching millions of kilometers into space. Inside that magnetic field, charged particles become trapped and accelerated to enormous energies. Io orbits directly inside this radiation nightmare. An astronaut standing unprotected near Io would receive a lethal radiation dose incredibly fast, enough to kill a human many times over within a single day. Even heavily shielded spacecraft suffer damage there. Electronics fail. Instruments degrade. Radiation slowly tears apart machinery at the atomic level. NASA learned this the hard way with the Galileo spacecraft. When Galileo entered the Jupiter system in 1995, engineers knew the radiation would be dangerous, so they designed the spacecraft with hardened electronics and protective shielding. It still wasn't enough. Over years of operation, radiation corrupted Galileo's memory systems, damaged instruments, and slowly blinded parts of the spacecraft. Yet despite all that punishment, Galileo transformed our understanding of Io forever. The mission observed gigantic eruptions in real time. It watched lava flows spread across the surface. It detected hotspots so bright they overloaded some of the spacecraft's sensors. Io was literally too volcanic for the instruments designed to study it. Then came Juno. Since arriving at Jupiter in 2016, NASA's Juno spacecraft has provided some of the sharpest modern images of Io ever captured. During close flybys in 2023 and 2024, Juno passed within roughly 1,500 kilometers of the Moon's surface. The images revealed fresh lava flows, changing volcanic deposits, and ongoing eruptions across the landscape. Scientists realized something astonishing: Io is not slowing down at all. Billions of years after its formation, the Moon remains just as violently active as it was when Voyager first discovered its volcanoes in 1979. That original Voyager discovery remains one of the most important moments in planetary science history. Before Voyager reached Jupiter, scientists assumed small worlds became geologically dead relatively quickly. Then engineer Linda Morabito noticed something strange in one of Voyager's images, a giant umbrella-shaped feature extending beyond the edge of Io. It turned out to be a volcanic plume erupting hundreds of kilometers into space. Humanity had just witnessed active volcanism beyond Earth for the first time. The discovery shattered old assumptions overnight. Suddenly scientists realized tidal heating could power geological activity on worlds far from the Sun. Without Io, researchers might never have fully understood Europa's hidden ocean or Enceladus' icy geysers. Io forced scientists to rethink what kinds of worlds could remain active and potentially habitable. Ironically, Io itself may be one of the least habitable places imaginable. There is no stable liquid water. No thick atmosphere. No protective magnetic field. Any water the Moon once possessed was likely stripped away billions of years ago by relentless heating and radiation. Europa may hide oceans where life could exist. Titan possesses lakes of methane and complex chemistry. Enceladus sprays water vapor into space. But Io offers nothing except fire and destruction. It is a world that has been cooked from the inside for so long that anything delicate was erased before it ever had a chance to survive. And yet, there is something strangely tragic about Io's existence. The Moon taught humanity how hidden oceans could survive in frozen worlds. It revealed the power of tidal heating. It changed the way scientists search for habitable environments across the universe. But because Io itself almost certainly cannot support life, it receives far less attention than Europa or Enceladus. Mission proposals to return specifically to Io repeatedly struggle for funding. Governments and space agencies naturally prioritize worlds that might contain biology because the search for life captures public imagination. Io has no life to promise us. Only lava. Only radiation. Only endless violence. So the most geologically active world in the solar system remains strangely underexplored. Still, Io may hold secrets far beyond our solar system. Today astronomers are discovering rocky exoplanets orbiting incredibly close to their stars, worlds heated by tidal forces so extreme that their surfaces may literally melt. Some exoplanets may even have global oceans of magma similar to what scientists suspect exists beneath Io's crust. In that sense, Io could be a preview of countless alien worlds scattered across the galaxy, planets locked in gravitational torture around giant worlds or massive stars, burning endlessly because of the orbits they cannot escape. And eventually, Io's own orbit may destroy it completely. Over immense spans of time, tidal interactions transfer energy through the Jupiter system. Some scientists believe Io may slowly spiral inward toward the giant planet. As it moves closer, tidal forces would intensify. The Moon would heat even more violently. Eruptions would become increasingly catastrophic. More material would escape into space. More stress would tear through the crust. Finally, one day far in the future, Io could cross Jupiter's Roche limit, the boundary where tidal forces become stronger than the Moon's own gravity. At that point, Io would no longer hold itself together. Jupiter would rip it apart piece by piece. The Moon would not crash dramatically into the planet. It would unravel. Mountains, lava plains, sulfur deposits, and molten rock would stretch into streams of debris orbiting Jupiter like shattered remains. Over time, those remains could form rings around the giant planet, dark volcanic rings made from the broken body of the Moon Jupiter spent billions of years squeezing apart. Saturn has beautiful icy rings. Jupiter may one day wear the remains of Io like a scar. Until that future arrives, Io continues its endless struggle. Volcanoes erupt in silence beneath a black sky. Lava rivers spread across sulfur plains. Radiation floods the space around the moon while Jupiter hangs overhead like a god too massive to escape. Io keeps burning because gravity refuses to let it die. And somewhere out there in the darkness of the outer solar system, an entire world continues tearing itself apart simply because it orbits too close to something too powerful. There is something deeply unsettling about Io once you stop thinking of it as just another moon and start thinking of it as a process. Because Io is not stable in the way Earth is stable. It is not balanced. It is surviving moment to moment inside a system designed to punish it continuously. Every orbit around Jupiter stretches the moon apart and compresses it again. Every eruption is evidence that the interior is still under unbearable stress. Io does not experience peace. It experiences interruption between disasters. And yet somehow, against every expectation, the moon endures. For billions of years, Io has remained trapped inside this gravitational machine. Long before Earth had oceans, Io was already erupting. Before the first complex life evolved on our planet, lava was already flooding across its surface. Dinosaurs came and went. Entire species appeared and vanished on Earth while Io continued the same endless cycle above Jupiter's cloud tops: squeeze, melt, erupt, repeat. Human civilization itself is less than a blink compared to the time this moon has spent being tortured by gravity. That scale is difficult for the human brain to process. We naturally think in years, maybe centuries if we try hard enough. But Io operates on geological time. Its suffering unfolds slowly enough that it almost appears eternal. A volcano erupts. A lava field cools. A mountain rises. Another collapses. Sulfur freezes overnight and evaporates again at sunrise. The moon destroys and rebuilds itself endlessly while Jupiter watches from above like an executioner with infinite patience. What makes Io truly terrifying is that none of this is accidental. Every part of the system reinforces the violence. Europa and Ganymede keep tugging on Io's orbit, preventing it from stabilizing. Jupiter's gravity flexes the moon constantly. The flexing generates heat. The heat melts rock. The eruptions reshape the crust, which changes how stress moves through the surface, which creates new fractures, which creates new eruptions. Io is trapped inside a feedback loop millions of years old. And the moon pays for it physically. Every second, material escapes from Io into space. Sulfur, oxygen, sodium, dust, all of it pulled away into Jupiter's magnetic field. Over immense spans of time, the moon is slowly losing pieces of itself. Not enough for humans to notice over a lifetime, but enough for the universe to notice over billions of years. Io is being consumed gradually, atom by atom. That reality changes the way you look at Jupiter itself. From Earth, Jupiter often seems majestic. Beautiful cloud bands. Giant storms. A king among planets. But from Io's perspective, Jupiter is something else entirely. A gravitational predator so massive that escape became impossible long ago. Io cannot move farther away because the resonance with Europa and Ganymede locks the orbit into place. The moon is chained there mathematically. Trapped by physics itself. And maybe that is the strangest part of all. There are worlds in the solar system that inspire hope. Europa might hide oceans where life survives beneath ice. Enceladus sprays water vapor into space like signals waiting to be answered. Titan has rivers, lakes, rain, and chemistry complex enough to resemble a frozen alien Earth. But Io inspires something different. Not hope. Awe. Fear. Respect. Because Io reminds us that nature is not built around comfort or survival. The universe does not care whether a world is habitable. Sometimes gravity creates paradise. Sometimes it creates hell. And Io is hell made planetary. A place where volcanoes erupt in silence under a black sky. A place where mountains taller than Everest rise beside lakes of molten rock. A place where the atmosphere freezes onto the ground every night. A place where radiation storms rage invisibly through space while Jupiter looms overhead larger than anything a human mind evolved to comprehend. If Earth vanished tomorrow, life would disappear with it. But Io would continue burning. Lava would continue pouring across sulfur plains. Plumes would continue exploding into vacuum. The moon would keep screaming silently into space long after humanity was gone. And maybe that is why Io matters so much scientifically. Because Io reveals how violent the universe truly is beneath the surface. It shows us that planets and moons are not static objects drifting peacefully through space. They are dynamic systems shaped by gravity, heat, pressure, chemistry, and time. Some worlds freeze. Some worlds drown beneath ice. Some worlds burn forever. Io burns forever. Even now, while you sit here on Earth, safe beneath an atmosphere and magnetic field strong enough to protect you from the raw hostility of space, somewhere nearly 500 million miles away another eruption is happening on Io. Another lava flow is spreading across the surface. Another plume is rising silently toward the stars. Jupiter is squeezing the moon again at this exact moment, flexing its crust, heating its interior, forcing it to remain alive through violence. And one day, far in the future, that violence will finally go too far. The orbit will tighten. The tidal forces will strengthen. Io's crust will fracture beyond repair. The moon that spent billions of years resisting destruction will finally lose. Jupiter's gravity will rip it apart piece by piece until nothing remains except rings of volcanic debris circling the giant planet forever. A moon destroyed not by collision,